different kinds of quadrilateral. So it just depends on the number of sides and angles of a quadrilateral, how the nature of side and angle varies. In terms of that, they get a special name. For example, this trapezium. Trapezium is what? They ought to have two sides parallel and two sides non-parallel. Two sides parallel, two sides non-parallel. In this case, we have these two sides parallel, but we have five sides. It has to have a trapezium has to be a quadrilateral, that is four sides. It has to have a four sides and two sides has to be parallel. Kite. This is also a special type of quadrilateral, and the side with the same markings. See, these two sides are equal, these two sides are equal. The consecutive sides, two consecutive sides has to be equal. For example, these two are equal, these two are equal. These are kites. These are not kites. Because why? Why? Because these are opposite sides and they are say parallel, or you cannot say parallel here. These are parallel, but in this kite they may not be parallel, but they have to be equal. So here these two are equal, but this is not a quadrilateral. There are more than four sides. Here also we have these three sides equal, but this is not equal. So we have to have a two consecutive side has to be equal. So we just need to observe in kite that kite has four sides, it is a proper quadrilateral, and there are exactly two distinct consecutive pairs of sides of equal length. Then we have parallelogram. So parallelogram is again a quadrilateral. So the name is coming from parallelogram. So it has some parallel in it. So the name is suggesting this. So it is somewhere related with the parallel lines. In this we have A, B, C, D. See, this AB is parallel to DC, AD is parallel to BC. In this case, AB is parallel to CD, but these two are not parallel. So it is not a parallelogram. Opposite sides have to be parallel, right? Opposite side, this is parallel to this, this is parallel to this. That is how parallelogram works. But there are certain more properties of parallelograms. Elements of a parallelogram. So there are four sides and four angles of a parallelogram. Four sides, 1, 2, 3, 4. Four sides and four angles, 1, 2, 3, 4. Four angles. And some of these are equal, right? And there are various terms which are associated with the parallelogram. This is a parallelogram ABCD. This AB and DC, these are opposite sides. AD and BC, these are opposite sides. Angle A and angle C, they are a pair of opposite angles. Another pair of opposite angles are angle D and angle B. AB, this one, AB and BC, these two, they are adjacent sides. This means one of the sides starts where the other is going to end. This BC and CD, these are also the adjacent side. Angle A and angle B are adjacent because they are on the same end of they are the ends of the same side. Angle B and angle C, they are also adjacent. Angle DC are adjacent, angle DA are adjacent, right? So what property does we get here? If you just go through this example, the opposite side of a parallelogram, they are equal. Opposite side of a parallelogram, these two are equal, these two are equal. So we can go ahead, and there are certain things which we can do, and we finally, these are just examples, you can just try it out. These are certain set squares being used. Now we see that if we just take a diagonal here, these are two parallel sides, and for a parallel side, this angle has to be equal to this angle, right? This angle has to be equal to this angle, vertically opposite. This angle has to be equal to this angle. So in this case, 2 is equal to 1 and 4 is equal to 3, right? 1 is equal to 2 and 3 is equal to 4. So in this case, if we take these two triangles, different triangles or set squares, we see that this angle is equal to this angle, this angle is equal to this angle, this diagonal is common. These two triangles are congruent. We have used the ASA property of congruency. So in this case, AB is equal to DC and DC is BC, is equal to AD. So opposite sides are also becoming equal. AB is equal to DC and BC is equal to AD. We have to find the parameter of the parallelogram, PQRS. So it is given, this is 7, this is 12. So we know that the opposite sides of a parallelogram are equal. So this is also 7, this is also 12, opposite sides. So 7 plus 12 plus 7 plus 12, that is 38 centimeter. Now angles of a parallelogram. Okay. See, let me just you just go through this activity. Here we find that the opposite angle of a parallelogram are of equal measure. So how to do this? See, again, we take a triangle, we take one diagonal, we take another diagonal. So two diagonals we have taken. So this AC and BD, these are diagonals. So 1 is equal to 2 and 3 is equal to 4, because we have parallel lines and this is a line joining these two. So this is equal to this is equal to this. So these two, 1 is equal to 2 and 3 is equal to 4. The angles are equal. Also, because these two are equal and this is a common side, so these two triangles are congruent. So if you take this ABC and ADC, ABC means this ABC, this one, and ADC, right? This one and this one. We find that because ASA we have used and they are congruent, that means that this B has to be equal to D, because these two are congruent. This angle has to be equal to this, because we have already seen that 1 is equal to 2 and 4 is equal to 3. So B has to be equal to D. So now the opposite angles are also equal. Let us take an example. In this we have BEST. This is B, this is E, this is S, this is T. This is a parallelogram. Find the value of XYZ. So what we have to do here is, this is quite simple. See, first of all, this is 100, and we know that opposite sides of a parallelogram are equal. This is 100, this means this is also 100. Okay, and since we know that this angle and this angle, Z and this are linear pair, that means if I take, so these two angles, this has to have addition as 180 degree. So this is 100, and this is what? This is, we don't know. So 100 plus Z will be equal to 180 degree, which gives you Z equal to 80 degree. This is what we get, right? So this is an idea that the adjacent angle, you can say that the opposite angles are equal, and the adjacent angle, they are supplementary. So from this example, we can just conclude that the adjacent angles in a parallelogram, they are supplementary. So in this ring, this is a figure, angle R is given 70 degree. So we have to find all other angles. So if this is 70 degree, then we know that this angle has to be 70 degree, opposite angle, and these two, this one and this one, has to add to 180 degree, because these are supplementary angle. So 180 minus 70 is 110, 110. This is 110, so this is also 110. Opposite angles are equal. So these are 4 angles. Diagonals of a parallelogram. So the diagonal of a parallelogram, they are not of equal length in general. They can be equal, they may be equal, but in general. But the diagonals of a parallelogram, they have very interesting property. The diagonal of a parallelogram, they bisect each other. The diagonals of a parallelogram, they bisect each other at this point. Means this side is equal to this side equal to this side. That means DO will be equal to OB and AO will be equal to OC. See? So how to get this idea? See, triangle AOB and COD are congruent. How? AOB, this one, this triangle, and COD. This is quite easy, because vertically opposite, this angle is equal to this angle is equal to this angle, and the opposite sides are equal. So these two are, we can also take this angle, vertically opposite. So, these two are congruent. So when they are congruent, DO equal to OB and AO will be equal to OC. This is the property which we are discussing, that the diagonals of a parallelogram, they bisect each other. So in this figure, HELP, this is a parallelogram. Lengths are given in centimeter. So if we are given this OE to be 4 and HL is 5 more than PE, this HL, this whole HL is 5 more than PE. So first of all, let us find out PE. This is 4, so this is also 4, because in the parallelogram diagonal bisect each other. So these are this is 4, this is 4. So just add it. This will be 8. Now what is being given? That HL is 5 more than PE. So just add 5 more. You get 13. So now we got HL. Now let us divide it by 2. This HO and OL will be equal to 13 by 2, that is 6.5. This is what OH is.